Good morning, class. Welcome to Rock Week. Today we're going to continue to learn about why geology rocks. Good. So the study of geology includes Earth's history and the processes that act on it. Can I get a volunteer to read the objective on the board? Shiny.
Okay. Objective. Students will be able to identify the 3 rock types of the rock cycle.
Very good. So we learned about different types of minerals. We had some samples in a previous class. And when you have a bunch of those minerals and you put them together, you get rocks. So today we're going to learn about how rocks can move in different cycles. They can move around the cycle because of different processes that we learned about, such as heat and pressure and erosion and other things like that. So we have our rock cycle here. And as Cassie pointed out, one of the rock types is called igneous rock. So igneous rock comes from the cooling of molten lava at the top of the Earth's surface. So later on we're going to talk about things like volcanoes and earthquakes and more exciting things like that. But when lava, or magma as it's called when it's underneath the surface, rises to the top and cools, it forms what is called igneous rock. Now tomorrow, after your homework, which I'll explain in a little bit, we're going to learn about the different types of rocks within a rock type. So you'll see that both of these rocks are both igneous rock, but they look very different. And we'll talk about why that is. So igneous rock, again, is the cooling of lava at the Earth's surface. Then, as Shivy pointed out, erosion is a force. So because of water or wind or other erosional forces, an igneous rock could break up into little bits called sediment. That sediment could be transported other places and then aggregate together or cluster together and form what is called sedimentary rock. Then that sedimentary rock, under heat and pressure, which we talked about underneath the Earth's surface, when it's exposed to that, it will transform into what is called metamorphic rock. So I like to say I sip milkshakes. I really like milkshakes. So I, igneous, sip for sedimentary, and M for milkshake. So that's just one way I remember it. So again, we're going to go into more detail tomorrow about why these rock pairs look different and all the different rocks. And I'd like to remind you that this rock cycle is really important for the foundation of geology. It's really important that we understand this in order to learn more about other parts of geology. And quickly, I'd like to ask you guys, why is geology important? Why does it matter that we know the difference between each of these? Why is the work of a geologist important for our lives or for us sitting here today?
Well, based on the presence of different rocks, could you tell like how much erosion has occurred in a certain place? Like if you see more metamorphic rock instead of sediments?
Yeah, very good. Yeah, definitely. So the type of rock in a certain place kind of shows the makeup of that area. Very good. How about more indirectly, how does rocks benefit us? When we talked about geology, we talked about how scientists who study geology work a lot with energy, right? So because of geologists?
So we can get light, electricity?
Yeah, very good. So you wouldn't necessarily think by looking at this cycle that that has to do with the lights that are on. Can you think of anything else?
Something to do with our water?
Very good. So we talked about yesterday with geology that they work to make sure that we have clean water. So because of knowing about rocks and where they are and how they're able to filter water, we can get clean water out of our sinks. Very good. Okay, so now we're going to do a quick think, pair, and share. So I have some Play-Doh for you. Did you guys play with Play-Doh as a kid?
Yes.
Did you eat any Play-Doh as a kid? Okay, so this Play-Doh is going to represent a rock. And I'd like both of you to work together and create the rock cycle. And then you're going to try it out, and then in a couple minutes or so, 2 minutes, you're going to present to the class of how you think you can portray the rock cycle with this piece of Play-Doh. So I'll leave it up to you.
So You start out with igneous rock.
Yeah, very good. You can look at the diagram.
So it would be kind of like this, because it's cooling and hardening. And sedimentary rock, you have to break it down. So we could rip it, maybe.
Yeah, good thinking. So you have igneous rock, you're breaking it up into little bits. And then remember, geology is the study of the Earth's history, and this keyword, processes. So what's the process that needs to happen to get to the next rock type?
Compaction.
And you also need transport. So you mentioned this earlier in the lesson, remember? And that was erosion.
Right. Okay. So then these pieces probably compact each other.
Yeah, and they probably do that a little bit of ways, right?
Yeah.
They don't just break apart
right.
and then cluster together. They move downstream or
In a different location.
Heat and pressure. So I guess it would pressure. Yeah.
Very good. And a challenge for you, so say you have metamorphic rock underneath the Earth's surface, how would you get back to igneous rock if it's already underneath?
So now it uses the heat to melt.
So it would melt underneath the Earth into magma, yes, because we learned that magma's underneath the Earth and lava's above the Earth's surface.
Right.
And then how could it get to the Earth's surface once it's magma?
An eruption.
Yeah. And we'll be learning about that in a couple days. All right, great. So if you guys would like to show us one more time that whole rock cycle.
Yes. Okay. So you start out with igneous rock.
And then through erosion, it becomes sediment. And then kind of goes all over the place.
Yeah.
And that in certain areas, compaction will occur. Then
With heat and pressure.
heat and pressure. And then it's the heat from the earth.
Yeah.
And it melts into magma. And then an eruption.
And back to
And then
igneous.
Yeah, very good. Very good. Yeah, you guys are experts now. All right, so your homework, I'd love for you all to go home, either on your walk through your neighborhood or outside the school. I'd like you to look for a rock. And if you could bring in a rock sample that's your fist size or smaller tomorrow, and we're going to learn about the different rocks within a rock type. So remember I mentioned that within igneous rock there's all different kinds that look very different. So we're going to learn about why that is, and we're going to, by the end of tomorrow's class, be able to identify our rock sample. Is there any questions about that? Great. So I have one more thing. I have an exit slip for you. This shows the rock cycle diagram, very similar to this one up here. So I'm going to put this down. And then before you leave today, if you could fill this out with each of the types of rocks. So I remember that with I sip milkshakes, but you may have your own way to remember. And once you do that, silently and individually do that on your own, hand that to me, and then you're free to move on to your next class. Thank you.